Another bola shape. The hyperbola does look like two parabola going away from each other. Okay. There's many parts to the hyperbola, so let's get right into it. Alright, let's look at this picture right here. Alright, the center. Center is still going to be HK. So right there, that is going to be HK when we look at our standard form of the equation. And a squared and b squared, we're still going to have that. So this value right here, this green line is plus or minus a going to the vertices. Okay, plus or minus a. The b value, let me change that to red. The b value is going to be this value coming up and down the conjugate axis. Okay, I didn't specify those names yet, but the transverse axis, if you will, you can see cuts right through the vertices and the focus and the center. The conjugate axis cuts through the center, but that's it. Okay, the actual graph of the hyperbola is this shape right here and this shape, but everything else is needed so we know how wide our how wide our hyperbola is opening up. Okay, very important. So once we know A, and let me get back to this here. So this red line right here is plus or minus B. Okay, coming down here, plus or minus B. That helps us figure out how wide what the slopes of these two asymptotes are here. Okay, so once we know A and B, we can then figure out how wide our how wide our hyperbola is going to be. And one thing that's very important, unlike the ellipse, if you notice, the distance between the focus and the center is longer than the distance between the vertex and the center. With the ellipse, it was the other way around. Okay, so in this case, C is still the value between the center and the focus, but what is different is C is now bigger than A, and minus C is bigger than minus A. Since the C value, C again brings us plus or minus, oh, this is yellow, it's hard to read. Plus or minus C gets us to the foci. Well, since C is longer than A, when we're finding C, we're going to treat C as the hypotenuse. Okay? C squared equals A squared plus B squared. Okay? Which means that your C value is plus or minus the square root of A squared plus B squared, which is a little different than the ellipse, and the main reason, again, is right here. With the ellipse, A is bigger than C, but the hyperbola, C is bigger than A. For hyperbola with the transverse axis parallel with the x-axis, like this one right here, okay, the x minus h squared over a squared will be our positive fraction. The y minus k squared over b squared will be our negative fraction, and that will equal 1. The opposite's true over here where the transverse axis is parallel with the y-axis. The y term will come first, and the x term will be your negative. Okay, so pretty easy to remember. A squared is always the denominator for the positive fraction. That's important. It doesn't matter if it's the largest or the smallest. It's always the positive denominator. Okay, and don't forget what A, B, and C are. A is the distance between the center and vertices. So let's look at one of these pictures. I'll just open this one up. Ignore that. Let's change the color here. Okay, so A is going to be, so right here is your center and there's your vertices. So right there is your plus or minus A. I guess I should have plus or minus here for all of these. And let's talk about C first. C is the distance between the center and your foci. Foci are usually right in there. Okay, so there's your plus or minus C. And B, I say B is either the rise or the run for the asymptote. Well, in the picture we're looking at right here, it's going to be your run. For the other graph over there, that's going to be your rise, and you can look at it there. But for this one, let me just change the color here. Okay, so here would be your B, the run. So I have plus B, and I guess that would be my minus B right there. That helps us determine the slopes of these two asymptotes. Alright, so these asymptotes, we need to know what the equations are so we can graph them so we know how wide our hyperbola is opening up. So how do we find them? Well, let's look at this picture here. Okay, has all the main pieces we need. We have our A's and our B's and our C's. Well, if you notice here, when your hyperbola is facing this way, okay, transverse axis is parallel with the x-axis, well then our slope here for the asymptote is either going to be up B over A, or it's going to be down B over A. Down B over A. Okay, so that would be the slopes for these two things. And we also need to know an xy point. Well, if you notice, they both have in common the same center, the HK. So if you want, we can figure out the asymptotes like this. We have y minus the k value because it goes through HK. And the slope, well, we said it's either going to be plus B over A or minus B over A. So this right here gives us our two asymptotes, if you will. And it's also going through the H value there. So this right here would be the formula for the asymptote. If your if your hyperbola is oriented the other way, like this, okay, so where your transverse axis is cutting this way, parallel with the y-axis, well, then your formula would look like this. It's still going through HK, so it's still this. Okay, the only thing that changes is what's my slope. Well, now, instead of going up B over A or down B over A, we're going up A over B, up A over B, or we're going down A over B, down A over B, which is going to make our slopes plus or minus A over B. And those are the two formulas depending on which way it's oriented. Let's look at this hyperbola. Okay, we're going to find the coordinates of the center, the vertices, and the foci, and we also need the equations of the asymptotes. Don't forget with the vertices, there's only two vertices, not four like in an ellipse. Okay, well, right here we have two squared terms, and it's the difference. The difference of two squared terms tells us we have a hyperbola. Well, just like everything else, we're going to go from this general form to the standard form by completing the square. So I'm going to put I have a 4x squared plus 32x. And we're going to add something. Minus 9y squared plus 18y plus something. And I'm going to move our constant over negative 91. Now, I want a coefficient of 1 here and a coefficient of 1 here. Okay, it makes our lives easier. But there's no common factor in the x's and the y's, but I do know there's something common here and something common here. When that happens, watch what we do. I need to take a 4 out in order to have a 1x squared, so do so. That's going to give us an 8x here, and we still have to complete the square. I need to take a negative 9 out in order to have a 1y squared. Well, that's going to give me a negative 2y then, plus something, equals negative 91. All right, now when we complete the square, that 4 and negative 9 don't go away. They're still part of our answer right there. Okay, minus 9. Well, if you remember, here's our b coefficient. Half of b is 4. That goes there. When we square it, we get 16. That goes right there. So half of 8 is a positive 4. Square it, you get 16. Over here, half of negative 2 is negative 1. Square it, you get a positive 1. Now, we didn't add 16 and 1. What we really did was we have a 4 times a 16 is what we added, and a negative 9 times a 1. Well, that is a 64 over here, so we have to add 64 to both sides. And a negative 9. So I also have to add a negative 9. Okay? This value right here comes out to be negative 36. Now, the standard form has that right-hand side set equal to 1. How do I make that 1? Well, if you divide by whatever you have, anything divided by itself equals 1. Just remember to do everything by the same value. Okay, now, here, this simplifies. I have a 4 over 36, which is the same as a 1 over 9, and a 9 over 36, well, actually a negative 9 over negative 36 makes that a positive 1 over 4. And anything over itself becomes 1. I want to be consistent, okay? This is now the negative fraction. This is now the positive fraction. let's always put the positive fraction first. Okay, so that's going to give us a y minus 1 squared over 4 minus x plus 4 squared over 9 equals 1. All right, there's our standard form. Oops, okay, there and there. Now, over here, we have the a squared is always our first term. And the b squared is always our, or shall I say, the first denominator and the second denominator, which is going to give us a plus or minus 2 for a and a plus or minus 3 for b. Okay. Let's start graphing some of this stuff. We have a lot of information now. So if we look at the graph over here, okay, here's our center, and right here we can tell that it's going to be a negative 4 comma 1, right there, negative 4 comma 1, negative 4 comma 1. All right, now the distance to the vertices is plus or minus a. This right here is a vertex, and right here is a vertex, and this distance right here is plus a, and this right here is minus a. All right, well, what am we adding and subtracting it to? The x or the y value? Well, we're going up and down the y-axis, so we're going from 1, we're adding and subtracting it to the 1, the y value, which is going to give us a negative 4. Hold on one second, let me make that a little, I've got to draw a focus in there somewhere. So this right here, this vertex is going to be negative 4, and I'm adding 2 to the 1, which is going to give me 3. And over here, this is going to be negative 4. I have 1 minus 2, which is negative 1. Okay, so there are those two vertices. Now the focus, the foci. Well, they're going to be somewhere over here and somewhere over here. I'm not sure exactly where, but this green, this blue and this blue, well, that's plus or minus C. I know it's getting crazy here, but plus or minus C. Remember, with a hyperbola, the C value is bigger than the A value. So we're going to treat the C as our hypotenuse when figuring it out. Okay? So that gives us this. We have C squared equals a squared plus b squared. Okay? Well, that means that C is going to be plus or minus the square root of, well, a squared was 4, and b squared was 9. So C equals plus or minus the square root of 13. Which means that I need to add radical 13 and subtract radical 13 to the y value of the center. So that is going to give us, well, the negative 4s don't change. I mean, we're not doing anything on the x values. That's still at negative 4. Right? Well, if we're at 1 in the center, then this is going to be 1 plus the square root of 13. And this is going to be 1 minus the square root of 13. You can leave it in radical form. If you want to give me the decimal, that's fine. All right, we've gotten everything there except for the equations of the asymptotes. Let's do that. Okay. And there. So now, since it's oriented this way, the transverse axis is parallel with the y-axis. Well, we have y minus k equals plus or minus the slope times x minus h. Okay, hk is the center. Now, what's the slope? Well, in this case, let's go back here. We have, let me do this in red. This is A, and this is B. This is A, and this is B. So we're going up A over B, or for the other asymptote, we're going down A over B, down A over B. All right, so then it's plus or minus A over B. Oh, that's a B. Okay, so then we have y minus our k value equals plus or minus, well, A was 2 and B is 3, x minus a minus 4. And there are the equations for these asymptotes right here. Let me make it a little bit bigger. Right there. Okay. That is the equation for these two asymptotes right here. All right, let's take a look at your outline. Okay, hyperbola today. So come to class, ready to do page 557 and 558.